first glance, this problem looks just like the last one. But if we look a little more closely, we see that these two have a different sign. So the original Q's are different signs. Now we see, if I were to put the -3 in the middle here, it would be repelled by this one and attracted by that one, and that's not going to work. So rather than putting the charge between them, I'm going to put it outside of them. I want to decide which side. Well, which of these two is going to attract more weakly? The two, or exert a weaker force. The 2 will, because it's 1/3 of the charge of the 6. As a result, I want to put the -3 closer to the 2 than it is to the 6. So rather than putting it out here, I'm going to put it over here. Now, the +2 will attract it. The -6 will repel it. My two forces are opposite in direction. They can be equal to each other. The force between the 3 and the 2, I'm going to call this distance x. Between the 3 and the 6, this distance will be 0.5 plus x. Force 3,2 equals force 3,6. Force between the 3 and the 2, k times 3 times 10 to the -6 times 2 times 10 to the -6 over x squared equals k 3 times 10 to the -6, 6 times 10 to the -6 over 0.5 plus x quantity squared. Before I do anything else, I'm going to simplify, cancel out stuff. The k's are gone. The 3 times 10 to the -6 are gone. This times 10 to the -6 is gone. And I have 2 over x squared equals 6 over 0.5 plus x quantity squared. Once again, I'm going to take the square root of both sides. Rad 2 gives me 1.414 over x equals rad 6 2.45 over 0.5 plus x. Cross multiplying, distributing, I will have, when I solve, x equals 0.68 meters. I need to put my answer in context. I defined it, x is this, so I want to say 0.68 meters to the left of the +2 charge.